right, this is a video with some extra problems from the Module 7, starting out with this number 1 that says the starting salaries in thousands of dollars of 20 graduates chosen at random from the graduating class of an urban university were determined and recorded in the following table. So remember, these are in thousands of dollars, so 44,000, 39,000, etc. Construct a frequency and relative frequency table using a class interval width of 4 and starting at 30.5. Okay, so you can, these are called grouped frequencies, and you have to either, if they don't give you directions, obviously you could figure out kind of how to set that up based on what you think the bin size should be. But we are being given the class interval width and the starting value, so we're going to set up our table using that information. So our groups that are classes that they have given us has to start at 30.5, and then we go, it has a width of 4, so you can add 4 to this, so that's 34.5. Now notice that they're using 0.5 because none of the values up here are decimals. So if we had gone 30 to 34, or say 31 to 35 or something like that, if we had that exact number up here in this list, it would be very confusing because the next class picks up where we leave off, and how would you know which one to put it in? So that's kind of the idea of this offsetting by a half a point. So then 34.5 to 38.5, that's going to include any salary between 35 to 38, essentially, $1,000. And then we have 38.5 plus 4, so that's going to be 42.5. And then 42.5 to 46.5, adding 4 each time, 46.5 to 50.5, and we do have a 51, so we need to go one more. So 50.5 to 54.5. Then we're going to make a tally, because that's usually the easier way to do this, that we will then convert into a frequency, which is the number of occurrences, a relative frequency, which is the number of occurrences out of total occurrences, so that turns it into a percentage, and then that's going to be how we're going to work the next part. So when I look here, this is any value between 31 and 34, essentially. So let's see, that would be 33, and that's it. So there's only one observed salary in this range. From 35 to 38, so there's 1, 2, 3 in that one. And then 39 to 42, so that's 1, 2, 3, 4, 5, 6, 7. Okay, and then from 43 to 46, so 43 to 46, I'm going to circle these this time. So 1, 2, 3, 4, 5, 6. And then 47 to 50. So that's going to be 1, 2. And then 51 to 54. There's only 1. So sometimes marking these out kind of helps. I usually erase it afterwards because I want to be able to see my numbers again. But that helps us kind of figure out what's in what group. Now, that was a total of 1, 3, 7, 6, 2, and 1. And you can kind of check yourself real quick by totaling this up. This should add up to the 20 we had. So that's what? 9, 10, and 10 is 20. Okay. Turn these into relative frequencies. You take the number of occurrences and divide it by total number of observations altogether. So 3 out of 20. I'm going to turn these into decimals, just writing them all down first. And 1 out of 20. So this is 0.05, 0.15, 0.35, just dividing these on a calculator, 0.30, 0.10, and 0.05. If you add all of these up, that should equal 1, okay, total probability, or 100% if you want to think of it that way. Okay, we're going to construct a histogram based on this. Now, I'm going to do mine the way the textbook did. They had two pieces here. They had the frequencies listed to the left of the y-axis, and then the relative frequencies listed also on the right. So kind of double marking, it's the frequency and it's the decimal. And then on the bottom, we need to have the starting. So there's two ways you can do, and we're going to put a little break here in the graph because they're starting at 30.5. If you use the midpoint of this class group, that goes in the middle of your bar on your histogram. But if you're using the actual endpoints, which is what I'm going to do, you put those as the start and end of each rectangle. So usually to save space in my math lab, they'll skip this one. So this represents 34.5, but they won't put it in just to save the writing space. So 38.5, skip 1. So then that would be 46.5, skip 1, and then 54.5. So those other ones are there, they're just not labeled. And then we usually label the bottom of our graph. I just kind of, mine got a little squished here. So it's starting salaries in thousands. Of dollars. Okay, and then I need to mark my frequencies and relative frequencies. So I'm going to start, looks like we can count by 0.05 essentially. So 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, and this had to do with one occurrence, two occurrences, 3, 4, 5, 6, and 7. Okay. The reason that goes nicely like that is because these are all essentially 20 times 5 is 100, so it divides evenly nicely. So you'll have to just reference what your values are and what their frequencies are to kind of figure out how to label this. So for this first one, we're supposed to have 0.05, so go up to that and then over, make sure you end. So since we're using our start and end as marks for our histogram, notice we go between those two marks for our width. And then we're going from the 34.5 to the 38.5. We were supposed to have 0.15 for that one. Oops, a little too wide. And then the 38.5 to 42.5, we're supposed to go all the way up to 0.35. Doing the best I can with this marker. And then for the 42.5 to 46.5, we're supposed to be at 0.30. And then from 46.5 to 50.5, we're supposed to be at 0.10. And then the last one, we're back down at 0.05. Okay, so there is my histogram. Then it has some questions for us. What is the probability that a graduate chosen from the sample will have a starting salary above $42,500? Well, above that would not be, see, this is $42,500, but that's not going to include that because all of our people in our items, they had nice even salaries. So 43 is the first thing above 42,500. So we're actually going to be adding up these last three. So this is 43 and above essentially. So probability that their salary is going to be greater than, or above, it doesn't say equal to. So above 42,500 is 0.3 plus 0.10 plus 0.05. Or 0.45. So 45% chance. And then what is the probability that a graduate chosen from the sample have a starting salary of at most? That means less than or equal to 38,500. So again, you can't use this one because we didn't have any items that were exactly 38,500. Our biggest, closest to that is the 38. So we're going to be doing the bottom two for that one. So the 0.15 and the 0.05. Which is 0.20. Okay, so there is that one. Now this next problem, I only did two from this first module because the biggest thing I think that's tricky in this is these finding the mean and medians from the ones that have grouped or class frequency charts. So you can't, like, when you find the mean, you're supposed to multiply your item times your frequency when you're doing a one that's a frequency distribution. And then you do that for each row, you add them all up, you divide by total frequencies. But we have this range of numbers here. So what we do is we find the midpoint of each of these. To find a midpoint, you add the two values together, 899.5, and then you divide it by 2. That's how you find a midpoint. So essentially, you're finding the average between the two values. So for this, what I'm going to be doing is I'm going to be just writing down what I found the midpoint to be out here to the side for each of these. And then we'll get over here, I'm going to make another column that's going to be midpoint times frequency. We will total that column up. We'll total up our frequencies. And it's going to be that the mean is the sum, oops, sorry, trying to write and talk at the same time. The sum of all items from 1 to k of x sub I, f sub I, so that's item midpoint times frequency, add all those together, and then we divide by total frequencies, which is n. Okay, so this is going to be n, this is going to be that big sum of all my items midpoints, because we need a singular value, times their frequencies, and then add it together. Okay, so the midpoint for this one, if I add those two numbers together and divide by 2, since it's two items, is 849.5. Add these two together, divide by 2, it'd be 949.5. Add the next two together, divide by 2, it's 1049.5. Add the next two, divide by 2, it's 1149.5. And then on the last one, it's 1249.5. So adding the two values together and cutting it in half. If we multiply the midpoint times the frequency on each of these, I get the following values: 2548.5 for the first one, 9,495 for the second one, because 949.5 times 10. If I do 1049.5 times 24, that's 25,188. 1,149.5 times 12 is 13,794. And then 1,249.5 times 1 is itself. Okay, add all of that up and we get 52,275. The frequency total, let's see, that is 22 plus 24. Oh, it tells us it's 50. Sorry, don't have to look, but it should add up to 50. So then our mean for this group is 52,275 divided by 50. So that mean comes out to 1,045.5. So there's my mean. Where this gets a little trickier is the median, because it's going to be based off of where is the middle. And the middle is kind of easier to see from kind of looking at a histogram first. And then we're going to, after we get the histogram kind of drawn out of what that looks like, we're going to solve a formula figuring out kind of where the middle is. We know that the middle should be the frequency that's exactly half of the total number of frequencies. So our position for that is going to be 50 divided by 2, which is 25. So why this is different is that this is kind of because of the area. So we're going to actually, so this has to do with half the area under the histogram. And the reason for that is, if you were to plot this histogram out, you know, you get your you've got all your midpoints, you do your frequency as the height of each of your rectangles. We're assuming that those have a base of the rectangle of 1. So it's the area of each of those individual rectangles is like 1 times 3, 1 times 10, 1 times 24, 1 times 12, 1 times 1. So if you add all that up, that's an area of 50. So half of the area under the histogram would be an area of 25. So we need to kind of figure out what marking point does that happen at. So first, let's go ahead and graph the histogram. Now, obviously, if we had an exact list of all of our values instead of just 3 things that occurred in this number group, we could just find the midpoint by listing them from least to, or the median, I should say. We could find that by listing them from least to greatest, and we know that an odd number, there'll be an exactly 1 number in the middle, and then if there's an even number, there's 2 numbers in the middle, and you cut it in half. This is different because we don't really know what these values are. We just know they're in this interval. So that's what we have to work with. So this is I'm going to count by 4s because I need to get all the way up to 24. So 4, 8, 12, 16, 20, 24. This is going to be my frequencies. Down here, I'm going to do a little break, and I'm going to use the midpoints this time since we have those figured out for ourselves. 849.5, 949.5, 1049.5, 1149.5, 1249.5. Okay. I actually misspoke real quick. I had to stop myself and pause for a second. This is the base of these is not 1. It's the width of the class. So this has a class width of 100 from here to here. So this is if you think about it, then if each of these has a width of 100 and we were to add all those up, that's actually 5,000. So this is 2,500. So that is going to play in when we do our equation in a minute. So you do have to know the width of your interval. That is the base of each of your rectangles. So when I draw this as a 3, what we're saying is that this rectangle is a 3 by, a 3 by 100. Okay, so we're going to use that when we write our formula. And then this one would be up to 10, which is about right here. And notice I'm going around this because this is a midpoint. This is the start and end of the interval as 899.5 and 999.5. So those are still those values. We're just looking at the midpoint. So this guy is a 10 by 100, and then 24 for the next one. So this is 24 by 100 for the whole rectangle. And then this is 12 for the next one. So 12 by 100, and then 1, which is really small, 1 by 100. So that does matter because when we look at this, we need to find where would half of the area. So if we shaded in everything here, that would be the full 5,000 area, okay? We're looking for where does half of that occur? Well, if you think about starting to multiply these areas up, we have 3 times 100, which is 300. Then we have 10 times 100, which is 1,000. So now we're at what, 1,300 total so far. If I do 100 times 24, that's going to be 2,400. That's going to put me over 2,500. So somewhere inside of this specific rectangle, and we don't know if it's dead center or not, but just somewhere inside here, we reach that mark of 2,500, which means whatever that purple line happens at, that number that it happens at, that is the median, because that's where half of the area would happen to the left and half of the area of this would happen to the right. So how do we know where that magical question mark number is? Well, the way that we set this up is we say, well, this is 999.5, the start of that box. So we know our median is the distance between wherever M and this number occur, so 999.5. So however far we had to go into our third bar, that's essentially what we're setting that up as. And then we have to times it by the height of this bar, so that's 24. Now, all of that together should equal the half area, okay? So that's why we had to have this number right. So again, base is 100 because of the class interval length. The heights are the frequencies. We wanted to know where half of the total area would have occurred. So if you think about 50 times 100, that is 5,000. So we were looking for half of the area being 2,500. As I started adding up the areas of my rectangle, I noticed that happened in the third bar. the mystery number that happens at is our median, and it's the median minus the starting value of that third bar times the height of the bar, plus all the previous, obviously, histogram bars that added up to this, okay? So if we work this out, this is 24M, let's see, that's 999.5 times 24, so that's 23,998 equals 2,500. We're going to add some like terms together. So on the left side, I'm adding all those numbers and subtracting the big one at the end. That's negative. So I have 24M minus 22,698 equals 2,500. Add that over. That's 25,198 equals 24M. And that is 1049.92. So it almost happened at my exact midpoint of that bar. It's just a little bit beyond that midpoint mark. So actually I would probably extend that and shade it a little more. But there is my median for this grouped interval. So these are a little trickier. And again, that's my fault for messing that part up right there. It does matter how far the class interval is, because that is going to affect that area and your formula over here. So that is the end of, I believe, the 7A, and I'll be working on the 7B.